Hey guys, hope all is well. So we're on lesson 6 today. You can see that we're going to be plotting points on the coordinate plane and determining the length of the line segment that connects those 2 points. And we can't count diagonal lines on the coordinate plane, so that's why the Pythagorean theorem comes into play. So if you could do the do now and then check yours with mine, and you'll see if it's correct. You should check over your homework answers that were sent, and I'll do some of the examples with you, and I'm actually going to ask you to pause the video and you try something and then check your answer with mine, because if we were in school you'd be doing those with your partner, and then you have the homework, which is the problem set. So give the do now a try and then check your answers with me. So these are the answers to part A and B. Part A was this horizontal line here. I just plotted the points and counted how many boxes long it is. It's 3 boxes long, so the length of this line segment is 3 units. And then part B, when I connected and counted the boxes, it was 10 boxes long, so the length is 10 units. I'll do C here. I just didn't want to put it on before because it kind of overlaps and I didn't want it to get confusing. Negative 1, 2 is this point here, and negative 1, negative 2 is here. So it's 1, 2, 3, 4 units long. And you can see that's pretty easy. You can count horizontal and vertical lines because they follow the path of like the graph paper, and you can count how many boxes long. But when it's a diagonal line, I can't count how long this line segment AB is because it's not following the lines on the graph paper. So what we like to do is turn this diagonal line into a right triangle. I could draw my right triangle here. I could have also drawn it here. It really doesn't matter. It's the same thing. The length of this horizontal line is 1, 2, 3, 4, 5, 6, 7, 8 boxes long, or 8 units. And this is 1, 2, 3, 4 units long. So since it's a right triangle, the legs are A and B, and across from the right angle is your hypotenuse C, so that diagonal line is C. To find the exact length, remember that word exact is a hint that you're going to leave like a square root in your answer. I have to do a squared plus b squared equals c squared, so I can do 8 squared plus 4 squared equals c squared. 64 plus 16 equals c squared. So 80 is what c squared is. So if I square root both sides, c is equal to the square root of 80. 80 is not a perfect square. It's close to the perfect square of 81, right? So 80 is not perfect. Therefore, the answer in exact is the square root of 80. We do the same thing for B. Now it says to the nearest tenth. So draw a right triangle. Count the horizontal and vertical lines, which happen to be the legs. 1, 2, 3, 4 units. 1, 2, 3, 4, 5 units. And this, I don't know how long it is. That's your C because it's across from the right angle. So I could do 4 squared plus 5 squared equals C squared. 16 plus 25 is C squared. So 41 is what C squared is. Square root both sides. C is equal to the square root of 41. That's an exact answer, but it does tell me to round. So let's get that calculator out. So on the calculator, I have to do the square root of 41. And to the nearest tenth, it would be 6.4. C is about 6.4 units. Why don't you give example 2 a try on your own? So hit pause and then check your answers with me. So hopefully you had this work. You found that the legs were 3 and 4. And remember, it doesn't matter which is your A and B, but C is always across from your right angle. So I wound up getting, in the end, that C squared is 25. I'm not done yet. I wanted to finish this in front of you. I square root both sides. C is equal to the square root of 25, but 25 is a perfect square. So I know that C is equal to 5. So the length of line segment DE is 5. I have to point out that this is a special right triangle since all of the sides, the 2 legs and the hypotenuse, turn out to be whole numbers. This is called a Pythagorean Triple. It's a famous right triangle, the 3, 4, 5 right triangle. Anytime you notice legs of 3 and 4, you know that the hypotenuse will be 5. So I actually give you permission, instead of plugging it into the Pythagorean theorem, if you notice it's this special 3, 4, 5 right triangle, as your work, you could say, oh, it's the special 3.345 right triangle, or you can call it a Pythagorean triple. Because if you recognize something as a Pythagorean triple, that means you have knowledge of the Pythagorean theorem, and that would count as your work. Let's take a look at the next page. So let's get through these quickly. We have to plot the points. Negative 5, 3 is P. 3, negative 4 is Q. And we have to find the distance. So this is a diagonal line, which means you're going to make a right triangle and use the Pythagorean theorem. So all of these questions really are done the same way. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7. So 8 squared plus 7 squared equals C squared. 64 plus 49 equals C squared. You could always have your calculator handy. 64 plus 49 turns out to be 113. 113 is not a perfect square, so I knew that it's going to be a crazy decimal. It does say round to the nearest tenth, so we use that calculator, and the square root of 113 is about 10.6. Number 2, we do the exact same way. Plot the points. This is F and G. Connect its diagonal. Whenever you have a diagonal line and they want to know the length of it, you make a right triangle. Everything is done the same way. You really probably already have enough knowledge to be able to do your problem set. We're going to keep on practicing now. So both these legs are the same. Remember, when 2 sides of a triangle are the same, it's called an isosceles triangle. So this is actually an isosceles right triangle. I'll do 7 squared plus 7 squared equals C squared. 49 plus 49 equals C squared. It does say exact distance, so I'm probably going to have to keep a square root in my answer. 49 plus 49 is 98, which is not a perfect square. It's close to the perfect square 100. So C is equal to the square root of 98. Done. I actually like it when they ask me to leave it an exact answer. It's a little less work, right? One less thing to enter in on a calculator. Here, in words, if the base of an isosceles triangle is 12 inches and the altitude is 8 inches, what is the perimeter? Okay, so this is a tricky one. Let's do this one together. So I'm going to draw something that looks like an isosceles triangle. These 2 sides will be the equal sides. Nowhere did it say that it was a right triangle, but it did say that the base, so this bottom, is 12 inches, and the altitude. The altitude is the line that goes from the highest point straight down. As soon as I draw a line straight down, I just made two right triangles. So that's going to be the important part in this problem. It's asking for the perimeter of the triangle. To find perimeter, you need to know the lengths of the sides. So I'm going to look at this one side on the right here. Notice it's part of this right triangle. If I drew that right triangle alone, I know that this is 8, but down here is not 12 because it's half of the whole thing, so it's a 6. So if I did the Pythagorean theorem, I would do 6 squared plus 8 squared equals c squared. So 36 plus 64. So 100 is c squared. I know that this is a perfect square. C is equal to the square root of 100, which means that C is 10. So this side here is 10. If I go back to my original drawing, if this is 10, the other side is 10 also because it's isosceles. Now I can finally find the perimeter. Perimeter means add up all the sides, not this 8 on the inside. I have to add the 10, and the 12 to find the perimeter of the triangle. So that's 32 inches. It equals the perimeter. That's the final answer to the question. Let's take a look at number 4. Find the length. All right, let's just draw a right triangle and count 1, 2, 3. 1, 2, 3, 4. Ooh, do you remember that famous right triangle, the 3, 4, 5 right triangle? If the legs are 3 and 4, the hypotenuse is guaranteed to be 5. So instead of doing a Pythagorean theorem for my work, I'm going to say this is a Pythagorean triple. If the legs are 3 and 4, the hypotenuse is 5. Next, find the exact length. That's like a giveaway that I probably need a square root in my answer. I'll draw a right triangle. This is 3, and this is 5. Now some people get fooled on this. They see a 3 and a 5 and they say, oh, the other side is 4. But remember that the hypotenuse has to be the longest side. So this hypotenuse can't be 4. It has to be bigger than 5. So this is not a Pythagorean triple. The Pythagorean triple that has a 3 and a 5 in it says that 3 and 4 are the legs and 5 is the hypotenuse. So we'll do 3 squared plus 5 squared equals c squared. Across from the hypotenuse is your c. 9 plus 25. So 34 equals c squared. Square root both sides. C is equal to the square root of 34. It says exact length, so I'm done. And now you can start your homework. Not so bad, only about a 13-minute lesson today. Good luck, and we'll talk to you soon. Bye. Bye.